Hi, it's Mr. Blatcher here. We're doing the third in our series of percentages pieces of work where we're running that into some on-math practice at the end. So there's quite a few questions in this one. I think we've got 9 questions that go with this set before you do the on-math story. So let's kick off with this then. So Hegedly Clip would be number 92 for this first example, but only the first 3 questions. Unless you want to do the rest of them, that'd be fine. So Mo's investing £500 in a savings account for 2 years, and the account is paying compound interest at an annual rate of 3.6% for the first year, but only 1.5% for the second year. Work out the total amount of money in Mo's account at the end of the 2 years to the nearest penny. Okay, so let's have a look at this then. So the first thing we're going to have to do is work out what's going on with our percentages. Okay, so I've got 2 percentages for the 2 years. Okay, so what I'm saying is, in a bank account, I'm going to keep 100% of my money. It's not a lose money. Okay, I'm going to get 100%, and for the first year, I'm going to have an extra, or after the first year, I'm going to have an extra 3.6%. So that's 103.6% in year 1. Okay, and then what's happened in the second year is we've got 100% plus 1.5% is 101.5% in year 2. Okay, so let's just have a think about that. So what we're saying is we're going to need some decimal multipliers. Okay, decimal multipliers, as in we're going to turn the percentages into decimals. So that's going to be 103.6 over 100 is equal to 1.036, and the other one is 101.5 over 100 equals 1.015. So there are decimal multipliers, right? So then what we're probably going to want to do is do part of the calculation. So we've got £500. There we go, £500. I need to multiply that by the first decimal multiplier, which is going to give me my £500 plus a little bit of interest. And then during the second year, I'm going to get interest on the £500. The little bit of interest I got, it's all going to get multiplied, so it'll be 1.015. Okay, so I need to do that on the calculator. So turn the calculator on. 500 times 1.036 times 1.015, and I need to press the SD button to get rid of that fraction. It's already rounded to the nearest penny. That's nice for us. Okay, so we get 5 to 5.77. Now the other way you can do that, if you like using the percentage button, so I'm going to say, if you want to do it a different way, you can do it this way, right? So we're going to just say I've got £500. I'm going to multiply it. I'm just going to use the percentage button now. I'm going to multiply it by 103.6%. I'm going to multiply that by 101.5%, and that is going to give me, hopefully, the same answer, right? So 500 times 103.6, and don't forget the percentage sign, otherwise you're going to get a really weird answer, times 101.5%, silly fraction, same answer. Okay, so 525.77, boom. Alright, okay, pause the video, you can have a go at the other question. Okay, so hopefully you've had a quick go at this. Let's have a look then. So what we're saying is we are going to end up with 103.6%. Again, we're going to end up with 101.5% again. So the DMs are going to be the same, aren't they? They're going to be 103.6 over 100. It's 1.036. And 101.5 over 100. That's 1.015. So we need to do the calculations now. We've got £1,000 in our account, right? £1,000 in the account times 036 times 1.015. We'll do that on the calculator. So 1,000 times 1.036 times 1.015 is £1,051.54. Okay, and if we wanted to do it that slightly different way, we would just say it was 1,000 times 103.6% times 101.5%. Do that on the calculator. 1,000 times 103.6 shift percent. Don't forget the percent button, otherwise it's going to go very badly wrong. Times 101.5 shift percent equals silly fraction £1,051.54. Okay, so that one's done. Okay, so we're on example 2 now, which is clip 94 in Haggerty, if that's where you want to go. So Siam, he's investing £1,500 in a savings account, £1,500 in a savings account for 4 years. Okay, and the account is paying a compound interest at an annual rate of 2.2% per annum. Annum, that just means per year. Okay, that's all that means. Right, so what we're going to need to do is just have a think about what is going on with the percentages. So what I'm saying is we're never going to be losing money in our bank account, so we're going to have 100% of our money, and we're going to add 2.2% every year, which is 102.2% every year, right? Okay, if we want to express that as a decimal multiplier, it would be 102.2 over 100, which is 1.022, and that's per year. So let's do the calculation then. So Siam's got £1,500. I need to multiply that by my decimal multiplier. Now what's going to go up here is for every year that I keep it in the account, I am going to take it to that index. Okay, so we can do that on our calculators. So we're doing 1,500 times 1.022, that little button there, drop a 4 in there, and we get 1636.42. We don't even have to do any rounding for that. Okay. And when we're talking about money and exam questions, usually you need to round to the nearest penny, because there's obviously in currency you can't have like half a penny or anything. So there's another way of doing this if you want to use your percentage button. I quite like using the percentage button, it requires a bit less thinking. So what we can do is we could say £1,500 multiplied by that business up there, 102.2%. Let's do that on our calculator. Oh, of course, but we need to take that to the power 4, don't we? Because it's 4 years. So 1,500 times 102.2. Don't forget the percent sign or you're going to get a really weird number. And we need to take that to the power 4 because it's in there for 4 years. And boom, we get the same answer, which is always nice to see because otherwise I'd be upset. Okay, I've had a go. Pause the video, you have a go. Okay, so what's going on with the Your Turn? So Haley, she's investing £1,800, £1,800 in a saving account for 5 years now. The account is paying her compound interest of 3.1% per year, per annum. Okay, we've got to work out how much money she's got after 5 years. Right, so it's the same sort of story. So I've got 100%, and hopefully I'm getting 3.1% extra per year. So it's 103.1%. So the decimal multiplier is 103.1 over 100. 1.031. So then we go ahead and we do the calculation. So Haley's got £1,800 now, and we're multiplying it by the decimal multiplier, and the number we need to put in the box is 5. So we can do that on the calculator, can't we? So 1,800 times 1.031. Take that to the power 5, and we get £2,096.84. And if you, like me, like doing it that other way, then you're going to be doing 1,800 times 103.1%. I need to take it to the 5, don't I? So 1,800 times 103.1, shift percent, don't forget the percent symbol. Oops, try that again. 1,800 times 103.1%, taken to the power 5, and hopefully get the same answer. 2096.84. Boom. Okay. Right, so it's example 3 now, so let's clip 95 on Hegarty. Ellie's buying her car for £2,029 in 2009, and the car is depreciating. Okay, it's depreciating 1.8% every year. Now depreciating means less valuable. Okay, it's less valuable, so it's becoming worth less and less money. So we've got to work out how much Ellie's car is worth in 2016. Okay, so a few things we need to work out here. So if we start off with Ellie's car and it's worth 100%, but it's getting less value every year, becoming less valuable every year, we'll have to subtract 1.8% from that. So 100% take away 1.8% is going to be 98.2%. Okay, every year. So our decimal multiplier for that is going to be 98.2 over 100, which is 0.982. Okay, so what we're saying is it's becoming only 98.2% as valuable every year. So how many years are there? So years. So we want it in 2016. Starts off in 2009. Okay, so 2016 take away 2009, 7 years, right? So what we're going to do here is we're going to say, well, what's the car worth? It's worth £2,029. It's going to be worth the decimal multiplier amount 0.982. But how many years am I going to do that for? 7. Okay, so we need to plug that into the calculator. 2029 times 0.982 to the power 7. Okay, so that is going to be worth £1,786, and we'll round that around to 74p. If you want to do that with the percentage button, you can do it a different way. Just quickly show you that. So that's just going to be £2,029, and now we're going to say we're going to use the percentage amount, so that's just 98.2%. Still have to take it to the power 7. It's 0.029 times 98.2. Don't forget the percent sign, otherwise you're going to get a weird answer. Take it to the power 7. £1,786.74. Same answer. Good. Okay. So I've done one. You can have a go. Pause the video. Have a go. Righty, let's have a look at that then. So Eli is buying his car, £5,000 in 2008. The car's depreciating 2.7% for every year. Okay, so 100% take away 2.7% is going to give us 97.3%. So as a decimal multiplier, 97.3 over 100 is 0.973. Okay, so how many years are we talking about? So 2017 take away 2008, so 2017 to 2008 is 9 years. So we need to do the calculation now. 5,000 multiplied by the decimal multiplier, and I'm going to take that up to the power 9. So 5,000 times 0.973, take that to the power 9. It's only worth £3,908 and 27.9p. So we're going to need to do a bit of rounding there, aren't we? 3908.279 ... is 3908.28. Okay, and if you wanted to do it that different way, you could have just said 5,000 times 97.3% up to the power 9. Okay, and you'll get the same answer, and we're done. Okay, so we're on example 4 now, clip 94 on the Hegarty. Slightly weirdy question, this one. So Harry's got £900 in the account. The account's paying compound interest at 1.1% per annum. How long will it take him to have £950 and 60p in the account? Well, let's have a look. So it's a bank account. We're not actually losing the money every year. So we've got 100% and 1.1% every year. So that's 101.1% every year. If we want that as a decimal multiplier, that is going to be 101.1 over 100, which is equal to 1.011. Okay, so what we're going to do is we are basically going to have a guess at how this is going to work. So I've got £900 times the decimal multiplier 1.011, and I'm just going to say, I don't know, 4, say, so just guess, and let's just see whether that's the right number. So 900 times 1.011 to the power 4. So that's 940.26. 940.26. Well, that's not enough money, is it? Okay, so let's try 900 times 1.011. Let's take it to the 5 now, right? So if you've got one of these calculators, it's nice because you can use these sort of arrow buttons and go back, delete our 4 years and make it 5 years. So I've got £950.60 now, which is what we wanted, right? So after 5 years is where we need to be. Okay, I've had a go, you have a go. Righty, so Harriet's got £800 in her account. The account's paying 5.5% interest every year this time. How long is it going to take her to have £1,163.74 in the account? Don't know. So we start off, we've got 100% in the account, and we're getting 5.5% every year. So we've got 105.5% every year, right? So the decimal multiplier is 105.5 over 100, which is 1.055. So what we need to do now is have a bit of a guess. We've got £800, multiply it by the decimal multiplier. I have literally no idea. Let's try 4. Let's see what we get. 800 times 1.055, take it to the power 4. Oh, hang on, whoops. Try that one more time. 800 times 0.55. There we go, 991, but that's not enough, is it? That's not enough. So I think we're going to need quite a few more years. So let's try 6 this time. 800 times 1.0. So remember to write all your workings down. I know it's a bit tiresome, but you get marks for this sort of thing. So we'll go back, delete that, make it a 6. So 1103. That's still not enough money. So we tried 6, let's try 7, alright? So go back, try 7. There we go, that's the right number, isn't it? Equals 1163.74, tick. That was after 7 years. Now, if you wanted to do that with the decimal, with the percentage button, you can do exactly the same sort of thing. I'll just quickly show you down there. So we're going to have 800 times 105.5%, if you like using the percentage button, and we'll take that straight up to the power 7. Right. So 800 times 105.5, don't forget the percentage button, don't forget to take it to 7 years, and it gives you your answer. Okay. Okay, we're done. Okay, so on example 5 now, still on clip 94 and Haggerty if that's where you want to go. So Hannah's investing £700 in a bank account. She creates a formula to show her that the money she has in her account M and the given amount of years that's in the account for N are related, like it says in the formula. Now this should be looking familiar because this is more or less what we've just been doing in the last example. Now looking at her formula, what is the interest rate in the bank account? Okie dokie, so have a look at this. So what we really need is that information there, right? So that's the decimal multiplier. 1.013 is the decimal multiplier. If I multiply that by 100, I'll get a percentage, right? So that's going to be 101.3%. Now that's not the interest rate. That's the 100% that's her keeping her money, and then the add-on bit over 100 is the interest rate. So what we need is 101.3 take away 100 equals 1.3%. Okay, that is the interest rate. Now we need to use her formula to check how much money is in her bank account after 7 years. Well, that's kind of what we've just been doing in the last example, really. So we're going to do £700. We're going to multiply that by the this business up here, right? Or in her formula, the piece of the decimal multiplier. Yep. And what we need to do is take that to the power 7. Right. So let's get my calculator. £700 times 1.013. Take that up to the power 7. So we're going to need to be careful with our rounding now. So that's 766.2388 and some other things. So when we round that to the nearest penny, which is always what we need to do, 66.24, isn't it? Okay, so I've done one. Pause the video, have a go at the other side. Okay, so hopefully you've just had a go at that. Just have a quick look at how you've done. So the information we need is in here. So the decimal multiplier was 1.025. If I multiply that by 100, I'm going to get 102.5%, right? But the actual interest rate would be 102.5 take away 100, that's equal to 2.5%. Okay. We need to use that formula to calculate how much is in the bank account after 9 years. So here we've got £900 now, and we're just going to multiply it with the formula we've been given, 1.025. What number goes in the box? 9 for the years. Put that in the calculator, so 900 times 1.025, 9. So we need to be a little bit careful again. So 11,239,766 ... So we need to round that to nearest penny. 1123.98. Okay, and we're done. Okay, up to example 6 now. So we've got a bit of a comparing type question here with the bank accounts. We've got Superbank and Great Bank, both offering different kind of interest rates. So Tia's got £1,300 to invest in the savings account, but only for 2 years. Which account is going to give her the most money, and how much extra will she get with the bank that's the best? So compound interest in Superbank is 1.7% for the first year and 0.8% for all other years. Well, there's only 2 years, so it's the other year. If we think about the decimal multipliers for that, like we've been doing in the other questions, so we need to add on 100% piece, don't we? So I'm going to have 101.7%, which is going to be the same as a decimal multiplier as 1.017. And here as a percent, that's going to be 100.8% or 1.008 as a decimal multiplier, okay? And we'll do the same on the other side. So I need to add the 100%. Right, so that's going to be 101.3%, and as a decimal multiplier, that's going to be 1.013. Okay, so it depends now whether you like using the percentage button on your calculator or the decimal multipliers. Okay, so she's got £1,300. So in her first year, she's going to be multiplying it by 1.017, or you can multiply it by the percentage if you like. The second year, it's going to be 1.008. Alright, so let's do that. 1,300 times 1.017 times 1.008, and we get 1332.6. It's going to round up, isn't it? 68. So 133. Okay, so that's what goes on there. And on the other side, I've got the same amount of money, but I'm multiplying it by 1.013 for 2 years. So we'll put a 2 up there. So 130 times 1.013. And we'll square that. And we've got 1334 point. I need to be careful about that, right? It rounds up. Okay. So which account has now got the most money in it, right? So Great Bank has got the most money in it. So Great Bank is best. Okay, there's best by, and we just need to subtract the numbers, don't we? So 1334.02, 1332.68. I'm going to subtract them. But I'm not going to do it manually, I'm going to do it with the calculator. Okay, so 1334.02 take away 1332.68, £1.34. Okay. Okay, £1.34. So I've had a go, you have a go. Right. Pause the video, give it a go. Righty, so let's have a look. So Tom's now got £1,500, £1,500. We've got the same banks but slightly different interest rates. So this is going to be 102.1%, but as a decimal multiplier it'll be 1.021, and this is going to be 100.8 as a percent, or 1.008, and this one is going to be 101.4%, or I guess 1.014. So then we could do the calculation, 1,500 times 1.021 times 1.008. So 1,500 so I've got £1,543.75. And on the other side in Great Bank Land, we've got 1,500 times 1.014, 2 years in the account. So 1,500 times 1.014 squared, £1,542.29. So which one is the most? That one is the most, isn't it? So Superbank is best. By, we need to do a bit of a subtraction, don't we? Who's got the most? This is the most. So 1543.75. Need to take away 1542.29. I'm going to do it on the calculator though. £1,543.75, take away 1542.29 is £1.46. Okay, and you're done. Okay, we're on example 7 now. So Camilla's investing some money in a savings account, and the account pays compound interest at the annual rate of 6.8% per annum. How long will it take for her to double her money? Okay, so I want to double it. And I don't know the answer. So what we're going to have to do is we have to remind ourselves about compound interest. So what we're saying is every year I've got 100% add 6.8%. So I've got 106.8% every year. Or I can think about this as a decimal multiplier of 1.068. Okay. So we don't know how much money there is, right? So that's okay. We don't really need to know how much money. We just need to know it's doubled. So if it was doubled, so we start with 100%. Double is 200%, right? So that's what we really want to know. So if we take our decimal multiplier, which is 1.068, and we have that for a certain number of years, I'm going to guess the number of years, right? I don't know, let's try like 10 years, okay? And see what happens after 10 years. And if you like doing it with the percentages, it's the same sort of thing, or I can have 100, let's do that in blue, 106.8% to the 10. Depends how you like to do it, but you'll be in the same kind of place. So 1.068 to the power 10. Okay, so reminding ourselves that as a going back slightly, so as a decimal multiplier that's 1.00, and 200% as a decimal multiplier would be 2.00, right? So that's 1.93. So let's just write that down here. 1.068 to the 10 is 1.093. Okay, that's not enough. So we're going to do the same again. I'm going to try it for 11 years now. So I'm just going to scroll backwards with my arrow key, delete the 0 piece of the 10 and make it an 11, press go. Oh, here we go. Right, here we go. So that's 2.0619. Okay. So we have doubled our money. And it took 11 years. Right, I've had a go, you can have a go. Righto, so let's go through that then. So back up here, our percentage is going to be 108.3% every year, and the decimal multiplier for that will be 1.083 as a decimal multiplier. So we start with 100%, we need to go to 200%, so we're going to have 1.083, it's slightly higher interest rate than before, so I'm going to start off with a slightly lower number of years guess. So I'm going to try 6, okay? So let's plug that into the calculator, 1.083 power 6. Okay, so that's going to give me 1.61. That's not enough, right? So we'll delete that and try 7. That'd be 1.747. Not enough still. 8 years. Make my 8 look a bit like an 8. That's going to give us 1.89. Still not enough. 9 years. Go back and delete that, make it 9 years. There we go. 2.04. That is the right number of years. It took 9. It takes 9 years. And we are done. Okay, we're at example number 8 now. Now, unfortunately, there's not really a decent Heggerty clip to go with this one. So you'll just have to put up with my YouTube version. So we've got Billy, James and Sam. They're going to the beach to collect sand. I don't know why they're going to collect sand. James collects 10% more sand than Billy. Sam collects 50% more sand than James. By what percentage is the amount of sand collected by Sam greater than the sand collected by Billy? Okay, so this is one of those things where we just need to just put a bit of effort into our layout of the question. So we understand what's going on and the examiner understands what on earth you're doing, okay? So Billy, James and Sam. So I've got Billy, James and Sam, okay? Right, now James is collecting 10% more than Billy. So let's say, right, Billy, he collects some sand, okay? It's what's called that 100% of sand, like a bucket full or however much it is, right? Now, James, he collects an extra 10%, right? So that is going to be 110%. Awesome, right? Now, Sam, he's collecting 50% more. So Sam is collecting plus 50% more than James. Okay, so we need to be very careful. So 50%, so basically that says 50% of 110%, right? That's what we're saying. So that is the same if you think about fractions and percentages. 50% is a half, and of is multiplying maths. So half of 110 Now half of 110 is 55, and this business here was in percent, so that's like, so we're adding 55%, right? So 110 plus 55 is what we're talking about. So that's going to be 165%, isn't it, right? So down then to the final piece of the question, which was, by what percentage the amount of sand collected by Sam greater than the amount of sand collected by Billy? All right, so what we're saying is Billy's got 100% of sand, Sam's got 165% of the sand, so 100 take away 165 take away 100 is equal to 65% more, right? Okay, hope that makes sense. So I've done one, you do one. Pause the video, have a go. Right, so here we've got Bobby, Jane and Sue. I know I'm feeling particularly, excited about my change of names there. So we've got Bobby, Jane and Sue. Alright, now Jane is collecting 20% more sand than Bobby. So let's say that Bobby's collecting 100% of sand, like a whole bucket full. Let's call a bucket full 100%. And Jane's collected 20% more. So that is going to give us 120%. Right. Now Sue is collecting 25% more. Okay, so she's collecting 25% more than Jane. Alright, so of 120. So we've got 25% of 120. If we think about fractions and our percentages, that's like saying, well, 25% is a quarter, isn't it? A quarter of 120. I mean, you can do that on a calculator if you like, but what we're saying is it's what is 120 divided by 4? That's 30%, isn't it? Okay, so we've got 120 plus 30. That's going to give me 150%, isn't it? All right. So we just need to do the sums now. So 150 take away 100 is 50% more. Okay, and you're done. Okay, we're at example 9 now, clip 811 on Hegarty. So the town of Wattle's got a population that is decreasing steadily, and it's found that the population is decreasing at a rate of 6.8% per year. Okay, so when we're talking about decreasing, that means it's getting less. So we're decreasing at 6.8%. So if we do 100 take away 6.8, we're going to have whatever's left, right? So it's going to be 93.2% left each year, right? Now as a decimal multiplier, we just need to divide by 100, right? So that's equal to 0.932. Now we start with 100% population, right? Now 100% of the population is 1 as a decimal multiplier, right? But we want to finish with less than 42%. Okay, now as a decimal multiplier, or as a decimal really, that's going to be 0.42. Okay, so there's a bit of sort of upfront work that we just need to have in the back of our minds. So what we're going to do is we're going to say 0.932 when I multiply that by itself for a number of years, I'll find out how many people are left in terms of a decimal, sort of like a percentage. So I'm going to guess, I'm going to guess 4. Okay, so that's just going to be a guess. I don't know if that's the right answer. Okay, so all will become clear, don't worry. Turn the calculator on. 0.932. Take that to the power 4, and I've got 0.7545. Okay, now is that less than 0.42? No, I've still got like 75% of the people left now. I've still got too many people. So I'm going to notch that up a few more people, right? Sorry, I don't mean a few more people, and a few more years. Let's try 8. All right. So we can use the arrow back option on our calculators here, and we'll delete that and make that 8 years now. Boom. So 0.569, so 56.9%. That's no good for us either. That's still not enough people gone down. So 0.932. Let's try 9. Okay, so go backwards, delete 9. 5305. Still not small enough number. Delete, put 10 in. 4944. That's not enough. Let's try 11. So we'll go backwards, delete that, make that 11. 4608. Still not right. Make that 12. 4295. Okay, that's still not enough people lost. So hopefully this is going to be the one, right? I hope so, because I've run out of space. 13 years, yeah, 0.4003. Okay, yes, so just get that back on the screen for you. So we are after the number in the box, 13 years. Okay, so I've done one, you have a go. So pause the video, have a go. Okay, so hopefully you've paused the video and you've had a go. So what are we saying? So some different numbers here now. We've got 8.7% is the decrease every year, and we want to get down to below 40%. So our decimal multiplier here is going to be, so what's 100 take away 8.7? Is 91.3%. So as a decimal multiplier, that's going to be 0.913, and our decimal multiplier here for the number we want to get to was we wanted 40% of the people. So there's a decimal multiplier that's going to be 0.40. So then we're going to have to guess, aren't we? So 0.913. Let's just start off. Let's try 9, right? So 0.913 to the power 9, 0.4407. That's not small enough. So we'll try 10, 4024. It's not small enough, and that was to the power 10. So let's try 11. Yeah, 3674. That's gone below 0.4, so we are good. So the answer is, after 11 years. And we're done.